Okay, we are live now. So again, you can find the material for this tutorial in this address. And you can see this PDF file. And the first thing you can do to run this tutorial is, well, you can use your the new framework for CROCO. But I'm still a bit lost in this framework because I don't know where is the okay, maybe I can do it here. Okay, maybe I can do it here also. Seems to be the CROCO code. Okay. Okay, you can work in this directory, but just for the good old times, if you want to make something that resembles the previous configuration, this is the last appendix in the last simulate from the last tutorial. You can edit this file. Maybe now we can add to this big job that they included all these configurations for Leftrarum here. So you can do all the code, all folders. You give that a name, and you have to put here all dev. Ah, this is commented. So here, all dev. This is the one that is not with a hashtag. So this one will work. You save this. Type create config.bash. Yes. And then you have your working environment like in the old times. But as you can see, it's very similar to this CROCO._in directory. So let's try it here also. And the size of this. So for all test cases, not only these related to sediments, basically for all test cases, what you have to do is the following. You edit the cpp devs.h, you compile with your job.com, you will find the input file, the arguments for this for each case in the directory test cases. You will see an input file for each case here. For example, if we do the RIP case, this is here. So you copy this to your directory and you run and you plot with tools that are here also. Here. So pretty much every test case has at least a simple plot that you can do. And these are some extra input files that are required for the sediment case in particular, with all the input configuration for the sediments that it was described in the morning. In a very few cases, you will also need this to do a previous steps. Most of these cases, they have an analytical grid or analytical forcing. But some of them will require these previous steps. So some of them create an input file with this. So we will take a look at this also. So let's go one by one. Let's see if we can, let's try the sandbar case. Yes. Okay, so what do I do if I want to do the sandbar case? I edit my cppdevs.h. I'm looking, I have to look for sandbar. I don't know, I think the order of the cases is historical more than alphabetical. So I define this one, and very important, I undefine regional. That is the default case. If not, I will have problems during the compilation. So define your case on the regional, and it was mentioned in the also, I think by Guillaume, you can make your own case. You can create a special section. Why? Because once you define a keyword here, then you have, that brings some other options that you have to look for. So let's take a look of what is being used in the sandbar case. Is the new coastal application that has sediment. That's very interesting. Biology. So okay, idealized configuration. Here we start with here. So, and the next thing that, so if sandbar is defined, and we define sandbar, it's not longer on def, given this conditional, all this applies. And you, in many cases, you will see the paper or the report that is connected to this particular case. Okay. And here's where you have to start. We have to read the code and see what is being used. For example, the sandbar case by default has MPI activated. Seems to be there's a non-Bosinesque option that, for example, here is undefined, is 3D, and we don't need a CROCO grid file, because here is here you see ANA-grid, that means analytical grid. The grid is defined in a file in an analytical way, and the initial condition is also analytical, flux is analytical, etc. You see that the code has only a western boundary, open western boundary, so it's a box with 3 closed sides. It has the wet-dry option, and if we do this with the non-bossiness option, then all this will be activated. The McWilliams-Restrepo wave current interaction. So here's the wave current. Here, the wave current interaction will act. Generic length scale mixing or LMD mixing, more classical. And we have BBL, this bottom boundary layer. This is all this comes if we have non-bossiness option. If not, we have all these other things. And we have sediment defined. That means that all this is being activated. No stations, no diagnostics, etc. So this is learn to read these configurations. Learn to read what is under the in the code. So let's save this. And what does this mean? Let me show you something else. Okay, so but when it says ANA-grid and initial, that means that there's a file called analytical.f that has all the analytical configurations. So you look for sandbar. Oh. Sorry, but it should be here. Let's see. Oh, okay, there's an analytical ANA-grid. I thought it was in this one. So I think that this is new. So there's a Fortran file for analytical grids. So you go, okay, my bad. So if you look for sandbar, you will see that there are some numbers defined. Depth 4 meters, Coriolis 0, beta 0, length 200. My guess is that is meters. And here you will get the definition, the shape of the sandbar is defined here. So you have this H, your depth. So just to let you know that things can be defined analytical, and if you want to code things by yourself, it's possible. Okay, so all these ANA things are in these analytical files. Okay, so let's compile that. Intel, Fortran, and since this takes.
Sorry, Andrés.
Yes.
I lost a little in the point 1.2.
Yes.
In the point 3, say copy the file from test case. What files? All point in? Or?
No, the one for your case. In the, for example, let me go to the same directory. CROCO. Okay, yeah, oh, it's finished. So I did this, I compiled and copied the in file from test cases. So I'm using the sandbar case, so I will copy from test case croco.in.sandbar. There are several. So let me copy all of them here. Okay.
Okay.
So now I can see that there are 3 input files that are for the default case, and there are 3 other ones that probably require the non-Bossinesc option activated. Yeah.
Okay, thanks.
So let's do 2 ways, move CROCO, this exit. Well, let's call it this Bossinesc. And here, meanwhile, I'm in the same directory. No. CROCO.in. Okay. So this is the one I did before that has sandbar. But now let's try with the with the POSINESC. Let me compile it. Meanwhile, we do this, the other stuff. Okay, this. Now we will compile it with this. And we can see the difference. Tell Fortran. So we leave this, we leave this compiling while we do this case. So copy and run. So let's see what we have. We have these three, we can do these three cases. We can see that in CROCO in sandbar, the default. So time step 0.1 second. All this, so this is about 1 hour, basically only 1 hour. It will read the input file here. So we don't need to copy this in our own directory because it will look for them in these test cases, Sediment sandbar 1B. This is what is going to be using in the default case. And the history fields for Sediment will be these. The bottom boundary layer history fields will be all true. All of them will be saved. Wave query interaction, etc., etc. And all this information will be saved in a file called sandbar.his.nc. And every 6,000 steps, we will get a sandbar. Every 3,000 steps. Okay, we will have a few of them. So this is where you see what will be written and how often, when. But we just learned that the time step here is 1/10 of a second. So we call executable. Yes. POSINESC, and we call this CROCO.in. Okay. Not working. Why it's not working? Why it was working? Oh, it's MPI, so must be using. I'm sure it was working yesterday. Number of nodes, and should be 4 instead of 1. Minus n equals 4. Okay, there's something, I'm not sure what's going on with this example, but the most simple thing will be to remove the MPI and run it at a slower pace. I'm guessing I will have the same problem with this one, NBQ, non-Mosilesk. I'm guessing I will have the same problem. Let's try CROCO.in.sandbar 1B. What is that? Maybe I need to send it with this. This one. What's the name of this? CROCO.in.sandbar 1B beyond BQ. Okay. We have some problems with this case, but pretty sure. Let me try to fix that while we see a more simple case that I'm pretty sure did work yesterday. So the RIP case, again, nano cppdevs.h. So again, okay, so define RIP, undefine all the other cases, save. Compile. Let's copy from test cases. RIP cases here. And we can look at these input files. Well, the RIP case is here, and so there's this case is based on a paper from Weir and Uchiyama in the year 2010. And has a few, these are the more will be an idealized case because you can define other things here. This also has MPI. Analytical tides can be non-Bosinesque. Etc. And the CROCO.in.rip time step of 4 seconds, also 1 hour. There's a grid. Here. I need a read file to work. And there's a sediment.in file that is needed. So copy from test cases, make rip to here. In test cases, I don't see a sediment.in for the rip, but here it is. Is in this directory. If we want to make rip, what this will do is to create a grid for the rip current experiment. And this has the option that to create a child grid for a nested domain. As a first step, we will not use it. So this we use Perch, the MATLAB, LD, MATLAB, start. Where is it? Where is it? I think it's this is not the classical, so let's copy it with the class from the classical. Expose. So the classical do have a start.m file. Starts and we make rip. I think there's a plot here that is not, okay, showing up. This is the bathymetry for the rip case. So it's uniform, but has some also an added variation in these dunes. But it's like this. But the most important from that is that now we have a read file. we compile this case. So we should be able to do CROCO, or let's move it. CROCO underscore rip. We type CROCO underscore rip. CROCO.in.rip. Why do I get this? No. It was working. I don't know what's going on. Okay. Let's steal this. It doesn't like MPI. Let's remove MPI. Yeah, there's a parallelization problem. But it's just parallelization, so I was expecting Rashid to be here, but oh, there's something there. I'm doing something wrong that I know. So there are some questions in the forum. There can be only one option defined. So if you define sandbar, you do have to undef regional. And you cannot define coastal either. It's a test case. So it's just one of those. The coastal is a new, is like regional but new. So like here. So we have defined RIP, but both coastals, these are the idealized simulation, these are the realistic ones, but we don't want a realistic one, we want this one idealized. So again, move CROCO RIP, and here this should work, please. CROCO.in.rip. Oh, there's something going on with MPI, and we heard a CPL condition blow up. Why? I don't need an input file. No. So first, notice that the first thing the model did was to create a wave field for our domain. So this has wave and currents. So CROCO has a small wave model inside, not wave watch. So the first thing this simulation did was to create a wave field for the domain. So it was this calculation. Once this calculation was done, it started the simulation, but for some reason, this blew up. Where in the borders? This is weird. Let me do something. Let me remove this grid. This should not work, but let's see if it works. No, it doesn't work. So if this blows up, we do what we can do is to decrease the time step. So it's 2 hours really, not 1 hour. This is the wave model. This is not funny. Why it's not funny? Because yesterday I did this in this account or a different account. Where was I? Not here. Check. Okay, I was in this account and things were working. CROCO.trip. Wave model, ocean model. I don't know why it's not working in this account, but on this other account, it does work. And this is what you should get. First the wave model, and then the calculation from the ocean model. Sorry, I cannot increase the font size in this. But basically, while I figure out why it's working in one and not on the other one, follow these steps. And let's see what happens. Edit, compile, copy the in file, run, and you're lucky and it works, do plot the MATLAB scripts. Okay. So there's not much more to do as far as demonstration. So I will stop the recording, but I will keep